and the fourth chapter is Analytical Chemistry. So here it is, I am writing the name of the chapter. So this analytical chemistry is nothing but practical chemistry. So the whole chapter is based on practical. So I will be showing you practically actually what you are supposed to do, what we will actually do it with respect to analytical chemistry. Now if this is practical chemistry, then will the theory question be asked from this chapter? And the answer is yes, both practically as well as also theoretical. Now both the questions will be asked from this chapter. So then what this analytical chemistry is all about? This analytical chemistry is about the test of cations. Now when I say cation, in the previous chapter also we discussed every compound is made of two parts. First part is the positive radical, which we call as cation, and the second part is what is the anion. So that means this chapter will tell you now how to test cation. Now there are so many cations. Since many cations are there, so because of which now you will see that in class 11 and 12 when you do analytical chemistry of class 12. So there you have to do the detailed study about all cations, like cations are divided into 0 group, group 1, group 2, group 3, that likewise we will have to do all the tests. But for you in class 10 in Icse syllabus they have given you only 6 cations. So that is why you have to be only, you have to learn only about the 6 cations. So you don't need to worry about other cations. Now what are these 6 cations and what we do or how we do? So before I give you the whole chart of the table, because if you remember this chart, it will be easy for you to answer the question, because in the theory questions, in the board questions also, this question based on practical will be asked. That is why if you know the chart, I will draw the chart. But before I draw the chart, see, I am going to tell you theoretically, I will also write reactions. Then after that, I will also be showing you practically how these practicals are done, in fact how these tests are done. Now then, any cation, for example, if I am writing one compound, the most common compound in this analytical chemistry is copper sulphate. So copper sulphate means since we are testing cation, we are testing copper. So any cation, 6 of them. Okay, let me write down what these 6 are. They are copper cation, 1. Then next one is iron. But since we have 2 iron cation, one is ferrous plus 2 and the other one is ferric, 2 iron. Then the fourth one is what is zinc cation. Then you have lead cation, and finally you have calcium. 1, 2, 3, 4, 5, 6. So this 6 cations is what you have to do or what you have to discuss. Now supposing if you are given a compound copper sulphate, copper sulphate is a salt. So what you do, take this salt in a test tube. I am telling now the procedure, what we do, and again by the way practically you will see also how you do. So just wait for some time. Again at the end of this video I will be also showing you practically how we go about doing this practical. So put this salt inside this test tube and then add water. Now when I say here water, don't forget that here we mean distilled water, pure water. Now add distilled water and now dissolve this copper sulphate completely in water. Now make a very clear solution of copper sulphate, very clear solution. Divide that clear solution of copper sulphate into 2 parts. Now why 2 parts? Now see, half of this, half here, the other half there. Now why 2 half? Because one you are going to test with sodium hydroxide, you have to test with sodium hydroxide solution, alkali, and the other one you have to test with ammonium hydroxide solution. So that means 2 tests you have to do. One is sodium hydroxide solution and the other one is ammonium hydroxide solution. By the way, don't forget, even though I have told you you are given copper sulphate, you are given copper and I am telling you what is to be done. But when you do the test, you don't know actually which cation is present. Actually you carry out this test and finally you will confirm that the cation present is copper, or cation present is ferrous or a ferric or a zinc or a lead, or it may be calcium. So that is why based on what you are getting here in the practical, you have to finally infer, you have to finally conclude what is the cation present. Now see, when you test sodium hydroxide, so now in this test tube, first you have to add few drops. Add few drops. Now when I say few drop, maybe you will add around 3 to 4 drops. Add 3 to 4 drops of sodium hydroxide. Again I am showing you practically how it is to be put. In fact, using a dropper, you will add 2-3 drops of sodium hydroxide. Immediately when you add drop of sodium hydroxide, you will find here a curdy, a kind of a precipitate is what is formed, a curdy substance is formed, that is insoluble precipitate. and this precipitate will have a color. So it may be pale blue, it may be white, it may be dirty green, or it may be any color. You will see reddish brown, different colors. Now I am going to give you a chart what are the different colors that you will see. So by adding few drop, you have to see what is the color of precipitate. So that precipitate which is there coming out. So as I said, different colors which will come out. So first few drop. Now once you have seen the color of the precipitate, now the next thing that you have to do is add Icse. First you added few drop, then follow it by Icse, means add plenty of sodium hydroxide. Now add plenty of sodium hydroxide in this, shake well and see whether this precipitate will be soluble or not soluble. So then after adding Icse, you have to see the solubility, whether this is soluble or not. By looking at the color of the precipitate and also by looking at the solubility, you can finally conclude by certain color which is coming out, certain color of the precipitate, and by looking at the solubility, you can conclude that the cation given to you in the salt is copper. Now what you did with sodium hydroxide, exactly same thing is what you do with ammonium hydroxide. Now in the second test tube, this test tube, now first add now few drops of ammonium hydroxide. Like how you have added here few drop of sodium hydroxide, same way you will add few drop of ammonium hydroxide. Now after adding few drop of ammonium hydroxide, you will see what is the color of the precipitate, and in almost every case when you are adding a few drop, what is the color of precipitate here? Same will be the color of precipitate there also. Now once you have seen the color, then add Icse, like how you have added here also Icse, here also you will write Icse. So add Icse, plenty of ammonium hydroxide add, then you see what happens, see the solubility, whether that precipitate is soluble or not soluble. So that means 2 times one particular solution that you prepare, divide into 2 parts. You have to test with sodium hydroxide also, you have to test with ammonium hydroxide. Yeah, I may not do all the 6 tests, you will see practically I will may be doing only 2 or 3 tests only I am doing, but then every test is done in the same manner. Yeah, solution prepare and divide into 2 parts. First test you will test with sodium hydroxide, and I told you already what is to be done. Theoretically I have said, practical also I am going to show you how it is done, and same thing here also. You add a few drops. So that means 2 main important reagents are there. One is sodium hydroxide and the other one is ammonium hydroxide. Now before I tell you the reaction which is taking place, what this precipitate is, that color precipitate, different color precipitate is coming out, what is that, what is the chemical name of those precipitate, after adding Icse, whether it is soluble or not soluble, all those reaction is what I am going to show. Since this is a very small chapter, short chapter, but since I am doing it practically as well as theoretically, so it may go a little lengthy, but then here, so what is the theory behind that practical that we do? So that is what you are going to see, but most importantly now I will first start with the chart now. So if you can remember this chart, then even though you may not be doing the practical, when the exam when the questions are asked, then by looking at this chart, this table, you will be able to answer the question. Yeah, then let us see now the table. Here copper cation, then ferrous, ferric, then zinc, then you have lead, calcium. Then the first test that we are going to carry out is test with sodium hydroxide. Yeah, sodium hydroxide solution. And the second test that you are going to do is by using ammonium hydroxide solution. So here the chart I am going to divide it into 2 parts now. Here. So this test, first part test is to be done with sodium hydroxide, and the second test is to be done with ammonium hydroxide. Now this sodium hydroxide test also, you know, it is of 2 types. One is, first you have to add few drops and see what happens when you are adding a few drops of sodium hydroxide. Then after that you also have to see what will happen when you add Icse of sodium hydroxide, because just now I told you theoretically, first we add a few drop and after that we add Icse. So in few drop, what is the color of the precipitate? That is what will come out here, and whether when you are adding Icse, whether it is soluble or not soluble, that is what you will write here. Same thing you will do here also. First you will add few drops of ammonium hydroxide, few drops, and then follow it by Icse. So you will add X's of ammonium hydroxide and see whether it is soluble. So that means this X's is only to see whether it is soluble or not soluble. What is soluble, not soluble? The precipitate. Alright, here copper. Now I am going to write one by one the color, different color, because few drop means you add few drop only to see the color of the precipitate, and you add X's to see whether it is soluble or not soluble. So that is why here copper. Immediately when you add few drop of sodium hydroxide, you will find in copper a precipitate comes out, that curdy kind of substance is coming out, and that curdy precipitate will have a color, and the color in copper is pale blue. So not very deep blue, okay, pale blue color is what is coming out. Same thing will happen here also. When you add a few drop of ammonium hydroxide, there also color will come the same, pale blue color precipitate. So yeah, don't forget this is a precipitate. Few drop means pale blue precipitate. Okay, if you want, I think I'll write PPT also. PPT means precipitate, pale blue precipitate. Again I am repeating, PPT here is standing for precipitate. So pale blue precipitate, color of the precipitate is pale blue. Then next one, if it is ferrous, if you are given any ferrous salt which has iron 2, then the color will be dirty green. So it will be dirty green precipitate. So the same thing happens here also. The good thing is that in both ammonium hydroxide and sodium hydroxide, you know, the color of the precipitate will be the same. Here also it is dirty green precipitate. Then if it is ferrous, then it is dirty green. If it is ferric, ferric, then the color will be reddish brown. So the color of the precipitate will be reddish brown precipitate. So here also it will be same, reddish brown precipitate. Now if it is zinc or lead or calcium, the problem now with these three is that all of them are same color, white color. But then also we distinguish them by, even though all of them are white, usually for zinc we call it gelatinous, like a gel, white color, but it will be gelatinous white. So here gelatinous white. This lead is what usually we call it as chalky, like a chalk, like how chalk powders are there, almost that kind. Yeah. So white precipitate. And here for calcium we will simply write it as white. So then what is here? Same thing here also, it is gelatinous white precipitate. So this is what is chalky white precipitate, and this, the only place where no precipitate is formed is here. So with calcium, when you are adding a few drop of ammonium hydroxide, there will be no precipitate formed. That's why I am giving a dash here. So that means, now the second table is what I have left it blank, because second table is to see now pale blue precipitate came. Now what will happen when you add X's? So then, now I don't want to write soluble, insoluble, soluble, insoluble. In fact, I think in short I will write this as soluble. So think that if I am writing right, then it is soluble. If I am writing wrong, means insoluble. Now what is soluble, insoluble? This precipitate which came out, all this precipitate which came out, when you add X's of sodium hydroxide or when you add X's of ammonium hydroxide, whether they are soluble or not, that is what I will represent now. When copper is tested with sodium hydroxide, when that pale blue precipitate is coming out, when you add X's, the precipitate will not be soluble. Whereas here it will be soluble. There also pale blue precipitate, but when you add X's, there it will be soluble. With ammonium hydroxide it will be soluble, but with sodium hydroxide it will not be soluble. Ferrous will not be soluble in both. In X's of sodium hydroxide also it is not soluble, neither it will be soluble in ammonium hydroxide. Similarly, ferric also not soluble in both. Zinc is the only one which is soluble in both. So zinc is the only one which will be soluble in this also, and it will be soluble in that also. Then lead is soluble in this, but it is not soluble in this. So it is soluble in sodium hydroxide, but is not soluble in ammonium hydroxide. And this is sparingly soluble. Sparingly soluble means little only it is soluble. So that's why I am not giving a tick, neither am I giving a cross, because little only soluble. So it is not as soluble as the other. But this calcium which is giving you a white precipitate with sodium hydroxide is sparingly, very little only it is soluble. Here there is no precipitate, there is no question of saying solubility, because precipitate itself is not there. So that's why here we will not be mentioning anything. Now I am moving aside, you see the chart, and if you can remember this chart, in fact you may be asked about different theory question based on this. I am moving aside so that you people can take the screenshot and make a note of this one. Very very important table to answer the question based on this practicals. Okay, so don't forget the color of the precipitate and also the solubility, because now see, especially why solubility required. Now you may say, sir, why solubility required? Because when these three are there, if you are only testing this sodium hydroxide, then everything is white. Then how will you know which is soluble? So then you may say, sir, soluble. So okay, I'll test solubility. If you test solubility, now see, both of them are same. White, white, soluble, soluble. That is why if you do this test, then the one which is soluble in both is zinc, and the one which is soluble in sodium hydroxide but not soluble in ammonium hydroxide, then you can say lead. So that way, when the color of the precipitates are same, this way we can identify by looking at the color of the precipitate and also by looking at the solubility in both the cases, we will be able to find out whether the given cation, whatever, see only 6 cations are there. These are the 6 cations. Even though many cations are there, as I said already, you will be learning in higher classes. If you still take science in class 11 and 12, there you will be learning about the other cations. But at such for you in class 10 syllabus, you only need to worry about these 6 cations. Yeah, this is what is the main table. Now, next I want to tell you what exactly is this pale blue precipitate or this dirty green precipitate, reddish brown precipitate, or what exactly is that? What is the chemical name of this? Now let me tell you beforehand that all these precipitates, this precipitate that you see are the hydroxide of the metal. For example, what is the chemical name of this pale blue precipitate? Then I will say it is copper hydroxide. What is that dirty green? Then it is ferrous hydroxide. It is ferric hydroxide, zinc hydroxide, lead hydroxide, calcium hydroxide. That means every precipitate that you see is the hydroxide of that particular metal. Now you may say, sir, how hydroxide came? Now I am going to show you by a reaction how that hydroxide comes. So that's why I may not be writing reactions for all. Maybe yes, I'll show you one reaction for copper. Maybe I'll show you for ferrous. Then maybe one more, maybe zinc and lead out of the two, because of the fact that they are soluble this side. So that means if you really remember, solubilities are 1, 2, 3, 4 place only they are soluble. Rest all of them are insoluble. Now when I say rest of them 1, 2, 3, then this you can say sparingly. So 3, 4, 5 and 6. 6 place insoluble and 4 place soluble, and 1 is sparingly soluble. So that way if you remember, because you may be asked a question, what will happen when you add a few drops of sodium hydroxide and then followed by Icse in any one compound. Like for example, I gave you copper sulfate. They may tell you in copper sulfate, what will happen when you add few drop followed by Icse? Then you have to say when you add a few drop pale blue precipitate, or if the question is asked about zinc, then you have to say gelatinous white precipitate form. Then when you add Icse, then you have to say soluble here. In this case also you have to say if it is there, so gelatinous white, then you know soluble in Icse. So that kind of question may be asked. But one more thing that you may be asked is the reaction. Now I'll show you some reaction based on this. Now what those precipitates are. Let's suppose I'll go with the first one. The most important cation is copper, because if you really see the previous board questions, you will see most of the questions are based on copper. So that's why copper I am going to write for both ammonium hydroxide as well as sodium hydroxide. Let us suppose you are given one salt. Okay, I think as I said, the most important salt is copper sulfate. You are given copper sulfate and then the question is telling you test what is the cation present in this salt. Now I am telling you in advance only that it's copper sulfate. But then in the exam, let's suppose you don't know what this is. Or even though you may be given that is copper sulfate, they may ask you what will happen when you add few drop followed by Icse. They may ask you sodium hydroxide, or more so in the exam they will ask more for this copper sulfate, they will ask with ammonium hydroxide. Okay, then let's see now. If you are given copper sulfate, then what you do? You prepare a solution. So practically you will see, and I have already theoretically also discussed. There you will add here a few drop of sodium hydroxide, few drops. Then you know double decomposition between the two. Actually you could have learned this in preparation of salt about this kind of reaction, but fortunately or unfortunately this kind of reaction from that previous chapter they have totally removed it. So exchange, simply think that copper is with sulfate, now copper will go and join with hydroxide and this sodium will come and join with sulfate. So that means it will give you now sodium sulfate and copper hydroxide. Here you are, copper hydroxide is formed, and sodium will go and join with sulfate to form sodium sulfate. Unfortunately, now you don't know which is soluble and which is not soluble. If you had done that previous chapter, preparation of salt, then every salt, what is soluble, what is not soluble, you could have learned. Now let me tell you, copper hydroxide is an insoluble base, insoluble. It is not soluble. That is why, as it is not insoluble, it is not soluble. That is why it is a precipitate, and precipitate is represented by the arrow down, and you know that arrow up means gases, whereas arrow down means heavy, precipitate. So when you add a few drops, this was few drops. You added only few drops of sodium hydroxide, and immediately you know a precipitate came out. And just now I gave you the chart. In copper, the precipitate color will be pale blue. So here it is, pale blue precipitate it is. Then what will happen if you add Icse now? Then if you look at this, in sodium hydroxide with copper, when you add Icse, it is cross. I have given you cross in the table. Cross means it is not soluble, insoluble. So this precipitate is not soluble. As the precipitate is not soluble, you don't need to worry. You don't have to write the second line reaction. Wherever there is soluble, I told you that 4 places soluble, 6 places insoluble. So wherever there lines, those tick lines are there, soluble, your life is a little burdened, because soluble means you have to write a double reaction. One more line reaction you have to write. But fortunately this is not soluble, so you have to write only a single reaction. So if you are asked, write the chemical reaction, here it is. And if you are asked, what is the chemical name of that pale blue precipitate, then you will say it is copper hydroxide. Just now, a little while ago, I told you that every precipitate is the hydroxide of that particular metal. Now let's write the same reaction with ammonium hydroxide also. Let's suppose in ammonium hydroxide, you are given copper sulfate, you have prepared the solution, and then you will add now few drop of ammonium hydroxide. Same thing, see what I am doing here, that was sodium hydroxide, now I am doing it the same thing with ammonium hydroxide. Here, few drops. Then again double decomposition, copper will go and join with hydroxide to give you copper hydroxide. Here, and then plus this ammonium will go and join with sulfate to give you ammonium sulfate. Here you are, this is ammonium sulfate. Again copper hydroxide, same copper hydroxide, see here also copper hydroxide, there also copper hydroxide. Again the same precipitate is formed. And since the compound is the same, here, that is why in both the case it was pale blue precipitate. So a pale blue precipitate is this copper hydroxide. So if they tell you what will happen, few drop, pale blue precipitate. Then there in ammonium hydroxide, if you see copper, you will see tick mark. Tick mark means soluble. That is why I was telling you, your life is a little difficult now when tick mark is there, because one more reaction you have to write now. If they tell you write the chemical reaction, then not only here it is only one because it was insoluble, but when it is soluble, not only this, one more reaction you have to write. Now then see how to write the second reaction, how it is soluble, why it is soluble. This is insoluble, that is why precipitate, but then how it becomes soluble. Now to write the second reaction, whatever product came on the right side, both will take part when you are adding Icse. So write both the products, right side. See, I am bringing it forward here. Copper hydroxide plus ammonium sulfate. Okay, so what are the product there in the test tube? A precipitate. There now you are going to add Icse of ammonium hydroxide. You have added some now more. Already you have added here few drop. Now here you are adding Icse of ammonium hydroxide. Plenty of ammonium hydroxide. Then there the reaction between the three, I would say two of them were already there inside the test tube. Now some more ammonium hydroxide we have added. Reaction will take place to give you a special salt which will come out, and that salt was not in your syllabus, but if you remember 6 different kind of salt, 3 only in your syllabus, but I said to you all 6 kind, and one of the 6 kind of salt was complex salt. A complex salt is produced. So in this case, what is that complex salt? Let's see. A special compound which is, okay, let me write first, then I'll tell you. This is called tetra. Tetra means 4. Ammonia is called amine, A-M-M-I-N-E. So tetraamine copper. Sulfate. So what is the name of this compound? Don't say copper, ammonia, 4 sulfate, not like that. We have to start from here. Again, I will repeat that this is what you learn, naming of such compound you learn in class 12. Again, there is a chapter called coordination compound. There you will learn about this complex compounds. So again, I am going to say tetra means 4, tetraamine or amine, tetraamine copper sulfate. And this salt which is produced is soluble in water. So let me write the name for you. It is tetraamine copper sulfate. Now along with this, there will also be a production of water. So that completes. Now this compound is soluble in water, and since it is soluble, previously a precipitate had come. Now why it is soluble? Now why we have given a tick mark? It is soluble because a compound which is produced, that is soluble, and this will give you a very nice color solution. Now you will see practically at the end of the video. So when I show you practically, this compound tetraamine copper sulfate is what we call as inky blue solution. A very nice color is what you will see, inky blue. If you don't want to say inky blue, you can say deep blue coloration. So the whole test tube, previously those precipitate, that curdy kind of substance will vanish. Curdy substance was this, that pale blue precipitate was this, but that pale blue precipitate totally vanishes. This is what is your reaction. So in case if you are asked to reaction C, you have to write a double reaction. So I told you, wherever tick marks are there, 4 places tick marks are there, you have to write a double reaction, because you have to write the reaction for solubility also. But where there are crosses, you have to write only one reaction, because this was not soluble, so no reaction. Yeah, this is what is a double reaction tick mark in case of this one. Okay, let me show you now how it is to be done your analytical chemistry, the cation test. I think the most important one is the test of copper. So here I am going with this copper test. This is what is you can see copper cation. So in the form of copper cation, I am taking a copper sulfate. Now see what are the observations that will be noticing. Okay, so what will do? So you will be provided with the salt. Now let's suppose, even though I am telling you well in advance that it is copper, but it is understood that you have to understand that this copper is something which you don't know. You are actually trying to find out that it is copper. You are trying to test and finally conclude that the sample which was given to you was copper. So what I am doing here, I have taken a small amount of the sample which contains copper. Now again I am repeating, you don't know that this contains copper. We are going to test. Now, so since this is the salt copper sulfate, so what I'll do, I need to prepare this, and don't forget, for all 6 cation you have to follow the same process. Maybe I'll show you the process for only copper, but don't forget the same process is to be carried out for all the 6 cation that I have shown. First you will put the sample in the test tube, and with this sample you have to prepare the solution. Now I'm going to prepare the solution. So, but to prepare the solution, I'm going to add some distilled water. So here, if you want, you can use tap water also. It's not going to make too much of a difference. But let's see, here I'm going to use distilled water to prepare this solution. So here I'm adding to it some distilled water so that I can prepare this solution. Here. So now you know that I'm trying to dissolve that copper sulfate. So till a clear solution, you can see now almost a very clear solution is what is prepared already. Now since I'm going to test this copper sulfate solution with 2 reagents, one is by sodium hydroxide and the other one is by, okay, here it is. So a very clear solution is what you have. So yeah, a clear solution, there is no precipitate, nothing is there. So yeah, a very clear solution. Now I want to test this with 2 reagents. One reagent which I am going to test is with your sodium hydroxide solution, and the other one that I am going to test is ammonium hydroxide. That is what I am going to do now. I am going to distribute this solution into 2 parts, so that one I can test with sodium hydroxide and the other one I am going to test with ammonium hydroxide. So let me distribute this. In fact, let me transfer half of the solution into the next test tube. Okay, you can see almost equal amount I have distributed. Maybe one test tube contains a little more than the other one, but then here in both the test tube now we have oxide solution. Now in one test tube I am going to test with sodium hydroxide and the other one I am going to test with ammonium hydroxide. Okay, so let's see what we or how we carry out the test. Now please understand that whenever we are testing with sodium hydroxide or ammonium hydroxide, so it is all about, okay, here I am taking sodium hydroxide now. So the first test tube I have taken. So this test tube I am going to now I am going to add in this sodium hydroxide. Now the process of testing is that first you have to add few drop. Now when I say few drop, maybe you'll add around 3-4 drops, and immediately after adding, so this is a very clear solution. You can see again, I'll show you that is a very clear solution, but immediately after adding few drop, you will find that a precipitate will be formed. A curdy kind of substance is what will be formed here, curdy. Now that curdy substance color is what you have to notice. So that means, so your test is in fact consisting of two parts. The first part is addition of a few drop. After adding few drop, you have to see the color of the precipitate. So you have to see the color of the precipitate. Then after that, once you have seen the color of the precipitate, then after that you have to add Icse. Now plenty of sodium hydroxide you have to add, and then see whether that particular precipitate is soluble or not. Okay, so first I am adding few drop, and you will see how nicely and very quickly, immediately after adding a few drop only, you will notice that the precipitate will be formed. So here it is. Now I am adding a few drop, very few drop of sodium hydroxide is what I am going to add now. So if I add, immediately as you add, you will find now the precipitate being formed. Okay, now check. Look at the kind of a precipitate which is formed. There you can see. A curdy kind of substance is what is formed. There you can see the precipitate and the color of that precipitate. So again, previously it was a very clear solution. Now a precipitate has what has formed. There you can see there a precipitate is what has formed here. Okay, if I okay, autofocus there is okay, there a precipitate is formed, and you can see that the color of the precipitate which is formed on the upper part, a curdy kind of substance which is formed, is what is pale blue in color. Pale blue, it is pale blue in color. That color is what is pale blue. In fact, that color is what is pale blue. So this very pale blue color is what actually distinguishes this copper cation from the rest. Now after distinguishing, after seeing the pale blue, now you can see very clearly. Now I think it's now more clear now. So so the autofocus is not letting me show you the clear picture of this one. Okay, here it is, a pale blue solution. Then now let us see whether it is soluble or not. I will add Icse and see whether it is soluble or not, whether this precipitate is really going to go or is going to remain the same. So I am adding now Icse. So if I am adding Icse, now you can see that the precipitate is not going. No matter what you do, now you can see the precipitate has not gone. So precipitate is still there. So precipitate has still remained there. You can see those curdy kind of substances still throughout the test tube you can see. So that means you can say now that the precipitate is not soluble. It is, again I am repeating, it's not soluble. Now the same test I am going to do now with the second reagent, and that reagent is what is ammonium hydroxide. Now let me discard this test tube now and take the other test tube. So if I am taking the other test tube, so here this reagent also I will discard. Now I am going to test with ammonium hydroxide. So here it is, ammonium hydroxide, and I am going to take the second reagent here, second solution. So this second solution also you can see a very clear solution. So you can see very clear solution of copper sulfate. There I will add a few drop. So just few drop only now here. Now you can see just few drop I am adding. Just 2-3 drop I will add here. As I add 2-3 drop, there you can see precipitate there on the top, even though it has become very dark blue, but then actually it should be pale blue because the ammonium hydroxide concentration is high. So because of that only, but still you can see a curdy kind of substance. You can see on even on the top you can see a curdy kind of substance is what is formed, curdy, and that curdy kind of substance is what we usually call it as pale blue. Now look at the lower part there, in the lower part here it is, you can see the curdy kind of substance is what is formed. So that very curdy substance is what is the precipitate. Again I am repeating, is pale blue. Now let us see what happens when I add Icse. So if I add Icse of ammonium hydroxide, plenty of ammonium hydroxide, now you can see the whole solution has become inky blue, and you know there is no trace of any precipitate now. You know the whole solution now, the whatever precipitate was there, whatever insoluble precipitate was there that was formed when I had added a few drop, now has vanished. Now we can say that the precipitate is what is soluble. Now I should also tell you that in theory also I think I will be discussing that. That precipitate actually was nothing but it was copper hydroxide in both the case, whether you are adding sodium hydroxide or you are adding ammonium hydroxide, the precipitate chemical name is your copper hydroxide, which is insoluble, that is why it is forming a precipitate. But when you add excess of sodium hydroxide, it was not soluble, so the precipitate did not go. But just now when I have added excess of ammonium hydroxide, you saw the precipitate was soluble. So a inky blue solution is formed, or if you like you can call it as deep blue solution is formed. And this deep blue solution also has a name. In this case, this name of this deep blue solution, which is soluble, is called tetraamine copper sulfate. Tetraamine copper sulfate. When I write the reaction, you will understand what I am actually talking about. This is what is tetraamine copper sulfate. So just now I have tested both. I have tested ammonium hydroxide also as well as sodium. Now let me show you both the test tube. So in the previous case, this was sodium hydroxide. See how much I had added sodium hydroxide, but still there are still lot of traces of insoluble precipitates are still seen there. You can see on the top part also as well as throughout the liquid. But if you look at the second liquid, second one, you can see nothing, no precipitate, no curdy, nothing. So it became soluble. So this remained as copper hydroxide only, that precipitate. But that precipitate has become soluble. It was soluble when you added excess of ammonium hydroxide, and it became tetraamine copper sulfate. This is what is the cation test for copper. Now let me show you one more iron also. Let me show you iron. There are two kinds. One is dirty green, and the other one is your reddish brown. So let me show you here. Let's suppose you are given one iron salt, ferrous sulphate. To this ferrous sulphate, when you add a few drop of sodium hydroxide, few drop, so exchange will take place. So ferrous will go and join with hydroxide to give you ferrous hydroxide. Here, this is the precipitate, which is dirty green. So dirty green precipitate will come out here. Then what will be next? Now the next part will be here. Ferrous has joined with this one, sodium will join with sulphate to give you sodium sulphate. So it is not soluble, so next reaction I don't have to write. Now same way, if I am testing the same salt with ammonium hydroxide. Now see what will happen if I am testing with ammonium hydroxide. If I am testing with ammonium, again exchange will take place. Ferrous will go and join with hydroxide to give you ferrous hydroxide. Here it is, again the same thing. Yeah, dirty green precipitate will come out because it is the same compound coming. And the other one is this ammonium will join with sulphate to give you ammonium sulphate. Here it is, ammonium sulphate. So again it's the same dirty green precipitate. So I don't have to write the second reaction because both of them are insoluble. In both the cases they are insoluble. Let me now take the next cation, and that is what is your ferrous sulphate. Here it is, I am taking ferrous sulphate. So there a little bit of the sample ferrous sulphate is what I am going to take and add it into a test tube. Here it is, I am adding into a test tube ferrous sulphate sample. Then there I am going to add distilled water. Here it is, I am going to add distilled water and prepare the solution. Here it is. Here. Now I am going to prepare a very clear solution of this ferrous sulphate. Now ferrous sulphate has all dissolved, as you can see. So it has all, since the test tube only is little dirty, so it looks like some precipitates. Okay, so but then a clear solution is formed. Now let me distribute this into two test tubes. So I am now transferring half of this into the next test tube. Here I have distributed almost equally in two test tubes. In one test tube I am going to test with sodium hydroxide, and the other one I am going to test with ammonium hydroxide. Now let us see what happens. First I am going to add few drop. Now in both the test tube, let me hold it this way and I will show you. In the first one I am going to add sodium hydroxide, few drop, just few drop. Here I am going to add maybe 1, 2, 3. Okay, 3 drop. Then I will also show you now what will happen when I am adding here 3 drop of ammonium hydroxide. Here I am adding 3 drop of ammonium hydroxide in the second one. 1, 2, 3. Okay, now I will show you there should be a precipitate form. Now you can see a precipitate is what is formed in both the test tube. There you can see very clear precipitate is what is there. So this precipitate for ferrous is what we call as a dirty green. You can see this precipitate is dirty green precipitate, the curdy kind of substance, and this is what we call as dirty green. So this was the test with sodium hydroxide, so they are dirty green, and in the second one also it is dirty green, because in both the case the compound which is formed is the same. In this is one, this dirty green precipitate is nothing but it is ferrous hydroxide, that is also ferrous hydroxide, because in both the case ferrous hydroxide is produced, that is why both of them are dirty green. Now this precipitate which are curdy in nature, curdy as you can see, very cloudy and curdy is what you can see in both the test tube. Second test tube was a little dirty, because of that only it is not coming too nice. Alright, then now let us see what will happen when you add Icse. So I am adding Icse of sodium hydroxide in the first test tube, it is in the first test tube, and I am also going to add Icse of ammonium hydroxide in the second test tube, here Icse. And even if you shake it well, okay, you can shake it as much as you like, but still the precipitate has not gone. You can see in both the test tube the precipitate is there. So in this also precipitate, they are curdy kind. Can you see that inside the test tube? So still the curdy kind of substance is still there inside the test tube. So that means we say that both of this, that is by using sodium hydroxide or by using ammonium hydroxide, in both the cases you know the precipitate is insoluble. This is what is the test of ferrous. Again I will say what happened with ferrous. In ferrous test, when you added a few drops of sodium hydroxide, a dirty green precipitate was formed, and when you added Icse, the precipitate was insoluble. Same thing happened with ammonium hydroxide. When you added a few drops of ammonium hydroxide, the precipitate form was dirty green, but when you added Icse, the precipitate was still, again in this case also it was insoluble. So it was insoluble in both the cases. Okay, now let me write one more reaction with zinc. I think I'll write, because zinc is soluble in both. So that's why the biggest problem is zinc, because zinc you have to write here also double reaction, because zinc is soluble in Icse of sodium hydroxide also, and zinc is soluble in Icse of ammonium hydroxide also. And similarly for other cations also you can write the reactions. Okay, let me write now reaction for zinc. Let's suppose we are given one compound of zinc, anything, zinc chloride, zinc nitrate, zinc sulfate, anything, something which is soluble would be better for us. So I think I'll go with zinc nitrate. Yeah, you are given zinc nitrate. So we are testing zinc. So again I am repeating, this can be anything, chloride, sulfate, or whatever you like you can write, but zinc, we are testing zinc. So let's first test with sodium hydroxide, and then after that we will be testing with ammonium hydroxide. Yeah, zinc nitrate, first you will prepare the solution, then add few drop of sodium hydroxide, few drops, 2-3 drops you will add. Then exchange between the two, zinc will go and join with hydroxide to form zinc hydroxide. Here it is, this is the precipitate. So the precipitate in this case is what is gelatinous white. Yeah, this is what is gelatinous white precipitate. And sodium will go and join with nitrate to form sodium nitrate. Here you are. So now if you look for solubility, then again you know here tick mark is there, but then when you write solubility reaction with sodium hydroxide, then you don't have to take both, like in case of ammonium hydroxide. In ammonium hydroxide, when I showed you the previous reaction, I took both. Here you don't have to, you only have to take the precipitate, because the second one will not take part in the reaction. Previously we took both because both of them are taking part in the reaction, but here it is only zinc hydroxide which will take part in the reaction. So this zinc hydroxide, when you add excess of sodium hydroxide, this was few drops. Previously you have added few drops, now here you are adding excess, plenty. Now the reaction between the two. So this one is also a base, this also a base. A special compound is produced, and that is what is called sodium zincate. Here you are, a special compound, as I said, a sodium zincate is what is produced. Now when this sodium zincate is produced, or in fact if you like you can call this as zincate, Z-I-N-C-A-T, zincate, usually we call it as zincate, but some people would prefer to call it as zincite, but it's not zincite, we call it as zincate, and along with this water. and this is something which is soluble, like previously how tetraamine copper sulfate was formed. Same way this compound is soluble, because any compound of sodium, they are soluble. So this is a colorless solution now. Now a solution, a precipitate, now it is no longer a precipitate. Precipitate has vanished now. This precipitate has vanished. So a colorless solution is what is produced, and that is what is sodium zincate. So here just now I wrote the reaction of zinc cation with sodium hydroxide. Few drop Icse. Same way zinc, let's do it also, ammonium hydroxide. Same compound let me take zinc nitrate, and when I add a few drop of ammonium hydroxide here, this is few drops, then again exchange will take place. Zinc will go and join with hydroxide to form zinc hydroxide, and then plus it will form ammonium nitrate. So again zinc hydroxide, same compound here, zinc hydroxide. So, I wrote up, arrow should be down. Okay, so zinc hydroxide is a precipitate. So again this is what is gelatinous white precipitate. Now when you add Icse, again there is a tick mark. Tick mark means one more reaction. And for ammonium hydroxide Icse, here I took only the precipitate and wrote the reaction with Icse. But for ammonium hydroxide, please note that we have to take both, because both will take part in the reaction. So I have to carry forward both of them. Here zinc hydroxide plus ammonium nitrate which was produced, and plus now you are adding Icse of ammonium hydroxide. Yeah, this is Icse. Now when you are adding Icse of ammonium hydroxide, now the reaction between the two, because every time when you are axing ammonia, and in only two places ammonia Icse is soluble, one was zinc and the other one is copper. Copper I have already written, and zinc also I have to write in the same manner. And a compound which is produced, and that is what is called here, this is tetraamine zinc. Okay, now previously I had written sulfate because the compound which I had taken was sulfate here. I had taken copper sulfate. Now I cannot write there sulfate because there is no sulfate here. I had taken nitrate. Since I had taken a nitrate, so you can see nitrate is there, so it will produce a nitrate here in fact. So what is the name of the compound? It is tetraamine zinc nitrate. By the way, this total has the valency of 2. Nitrate, you all know that has a valency of 1. That is why when you are writing the formula, it should be like this, that valency 2 has shifted there. So again I am repeating, what is this? Tetraamine zinc nitrate. Supposing if I had taken here chloride, zinc chloride, then I will have to write chloride. If I have taken there sulfate, then here I will be writing sulfate, and then plus water. So previously it was an inky blue solution. Now this is not inky, this is a colorless solution. So this is a colorless solution, and because of that colorless solution only, now the precipitate has vanished. So this way you can write reactions for all other cations. The most important one, the most complex one, zinc, because zinc was soluble in both, that I have already written. And also copper happens to be the most important, especially copper with ammonium hydroxide, because in the board exam copper question they have asked plenty of time. Don't forget, few drop, then pale blue precipitate in copper I am talking about. Then when you are adding Icse, then it is not soluble in sodium hydroxide, but it is soluble in Icse of ammonium hydroxide. And the solution which is coming out is an inky blue solution, a very nice color. So now you will see practically what is that. So that kind of solution is what is coming out. Now finally, your syllabus mentions something about the action of alkalis on certain metal, and especially the metals are they have mentioned is amphoteric metals. Now amphoteric metals are those metals which can react with acid also, as well as also can react with base to liberate hydrogen. So now especially 3 amphoteric metals, just now in the cation test also we have done 3 amphoteric metals, and they are zinc, lead and aluminum. Even though others are there like antimony, arsen, they are also amphoteric, but mainly we will only be discussing these 3 amphoteric metals. How do they react with alkalis? Especially now when I am talking about alkali, I will be taking either sodium hydroxide or potassium hydroxide. Okay, now since it is all about reaction only, now if a zinc is dropped in a strong alkali, NaOH or a KOH, so a metal which can react with acid, you know zinc can react with acid also, in that acid chapter we have discussed already. Zinc can react with acid, it is higher than hydrogen in the metal activity series, so it will react, it will displace hydrogen. Same way this metal, amphoteric metal, this 3 amphoteric metal can also react with a base, and here also it will liberate hydrogen. So then zinc will react with sodium hydroxide to produce a special compound which is your sodium zincate. Like in the previous case also we had seen this, this is sodium zincate. And along with sodium zincate, here hydrogen is what is released. Yeah, your syllabus also mentions not only metal but the oxides and hydroxide of the metal. So if only metal is there, it will give you hydrogen. Now supposing instead of metal, if you are given a metallic oxide, now if zinc oxide is there, then what will happen? Same reaction will take place. So again here sodium zincate will come out, but the only difference will be here water is produced. So if it is metallic oxide, then water. If it is only a metal, then hydrogen is what is coming out. By the way, same reaction I can write for potassium also. Here we have taken sodium hydroxide instead of sodium hydroxide. Like here, if I write zinc plus potassium hydroxide, then here sodium zincate, now here potassium zincate will come out, and then plus hydrogen. If it is zinc, if I am taking zinc oxide, then here it will come potassium zincate again, plus water will come out. So this is how the alkali, strong alkali like sodium hydroxide and ammonium hydroxide, sodium hydroxide and potassium hydroxide will react with this amphoteric metals. Now if I am going with next one, Pb. If you are dropping Pb in NaOH or KOH, let me not write KOH, so you will understand how I have written the same way you can write this for KOH. Then for Pb, then it will produce sodium plumbite. Now like how we have zincate, same way we also have plumbite. Now in case of plumbite also, since plumbite has a valency of 2, so here this plumbite has a valency of 2, like how zincate has a valency of 2, that I wrote 2 there, same way plumbite also has a valency of 2, and then in this case hydrogen is what is coming out. Now instead of lead Pb, if I am taking lead oxide PbO and plus NaOH, then same product is what will coming out, PbO2 plus this will be water. Yeah, by the way, I did not write the name of the compound, I am saying it, this is sodium zincate, this is sodium plumbite, valency 2, sodium plumbite. Here in this case water, because of that oxygen water was produced, there is no oxygen, so because of which hydrogen is produced. Now let me write for that aluminum also. Now what will happen to the aluminum? When aluminum is dropped in a strong alkali like sodium hydroxide and potassium hydroxide, then it will form sodium meta-aluminate, AlO2. Now you all know that meta-aluminate has a valency of 1. So since meta-aluminate has a valency of 1, so that is why that 2 I did not transfer here. Sodium also has a valency of 1, and meta-aluminate also has a valency of 1, and then in this case hydrogen. So since both of them have the valency of 1, 1, so I did not write that 2. Here also 2, there also it was 2. Now if instead of aluminum, if it is aluminum oxide plus sodium hydroxide, then here again you have sodium meta-aluminate, this is meta-aluminate plus water is what is produced. This is what is the reaction of this amphoteric metal. Again I am repeating, these metals are called amphoteric metals. So amphoteric metals are those metals which can react with acids also, and they can also react with base to liberate hydrogen. You can see all amphoteric metal has liberated hydrogen from base. Yeah, from this base hydrogen, there also hydrogen, there also hydrogen. So in fact these metals can react with acid also, dilute acid also to liberate hydrogen. So they are amphoteric metals. With this it completes your chapter. Again like the previous chapters, now you will be doing the questions from the exercises, especially priority should be your previous ICSE questions. Do it there in the book itself, mark it with the pencil in the book, and maybe yes you can click the photographs of the solved exercises and send it to me in my WhatsApp. So till our next class, goodbye and thank you.